Hi, I'm Paul Kilgan from GK Tuition, and in this video I want to talk to you about complex numbers. Now the question that I've chosen to go through here is 2017 Paper 1 Question 2 Part A. In this question we're given the complex number z is equal to minus root 3 plus I. And we're asked to use Demoys Theorem to find z to the power of 4. Use Demoys Theorem to get this to the power of 4. Now, the first thing that should jump into your head is that in order to use Demoys Theorem, we need our complex number in polar form. So at the moment, we've been given our complex number in rectangular form. Rectangular form is probably the one you're more comfortable with. It's when they write a complex number in the form of a plus bi. That's referred to as rectangular form. In this case, my a is the square root of 3 and my b is 1. But I want it in polar form. So to get it in polar form, it's or times the cos of theta plus I times the sine of theta. So I should be able to rewrite my complex number in this form, where or in this case is referred to as the modulus. So or is the modulus and theta is the argument. So basically there's two steps to converting your complex number into polar form. Step 1, find the modulus. Step 2, find the argument. So let's start off by finding the modulus. We have a formula to find the modulus of a complex number, and it's simply the square root of a squared plus b squared, where in this case clearly my a is the square root of 3. So in this case, if I'm subbing in, it just becomes minus the square root of 3 to be squared plus my b in this case is 1. The coefficient of I is just 1 plus 1 to be squared. So I'm just subbing into my formula, and if you plug all that into your calculator, you'll work out that in this case the modulus is 2. So or is equal to 2. Now to find the argument is a little bit trickier. And in order to find the argument, I want to draw your attention to the Argand diagram that I've drawn over here. So my horizontal line represents the real values and my vertical line represents the imaginary values. I've subbed in the complex number minus root 3 plus I. Where this is where roughly where minus root 3 is, and this is where 1 is on the imaginary axis, which means that this coordinate here is minus root 3 plus I. Now again, this is just for my own rough work, so you can just draw a rough sketch of this in your solution. I want you to recognize what the modulus is in the context of this graph. The modulus is the distance between the complex number and the origin. So I know the distance from my complex number to the origin is 2. Okay, now in order to get the argument, the first thing that I want to do is I want to find this angle here. And for the moment I'm going to call this the angle A. Okay, this isn't actually my angle theta, it's the angle A. And in order to find the angle A, I'm going to form a right angle triangle. I'm going to draw a line straight down from my complex number to the real axis. And now you just need to think of junior cert trigonometry. I know the opposite adjacent and the hypotenuse of this right angle triangle, so I could easily find the angle A. In order to do this, I'm going to use the fact that I know the opposite is 1. I know the distance from here to here is 1, so the distance from here to here is 1. And I know the adjacent, I know the distance from the origin over to here is the square root of 3. So I know the opposite and I know the adjacent, which means I can use tan. I can say that the tan of A is the opposite over the adjacent. In this case, the opposite is 1 and the adjacent is the square root of 3. Now, you have two options here. You can solve this question using radians, you can solve this question using degrees. Now, in this solution, I'm going to use degrees. But I want you to go back, when you finish this video, I want you to go back and try and solve this question by using radians. So basically, you can actually read this answer off your log tables on page 13, or you can use your calculator. So to get A on its own, I can say that A is equal to tan inverse of 1 over root 3. And if my calculator is in degrees, that'll tell me that the angle A is 30 degrees. Okay, so in other words, it's telling me that this angle here is 30 degrees. Now I want to go back to my argument. I'm looking for theta. Theta, or the argument, is the angle that the complex number makes with the positive sense of the real axis. What they mean by positive sense of the real axis is you start on the right hand side and you go in this direction. So my theta is this angle here. It starts here and it goes to here. Now you'll notice it's going to be very easy to find this angle now because I know that this is 30 and I know that the whole thing would be a straight angle. Then it's very easy to work out what my theta is. Just think of your unit circle in your trigonometry. How do you usually find an angle in the second quadrant? I know in class the way I always explain it is to get a value in the second quadrant, it's 180 degrees minus your reference angle. So in this case, my theta would just be 180 degrees minus 30 degrees. So I know that theta, or the angle that the complex number makes with the positive sense of the x-axis, is 150. So now I know my theta and I know my modulus, which means now I can apply my Demoys theorem. So I can rewrite my complex number minus root 3 plus I in the form of or cos theta plus I sine theta. So in this case my or is 2 and my theta is 150. So it becomes 2 times the cos of 150 plus I times the sine of 150. So for me really, whenever they mention Demoys theorem, the tricky bit and the bit that catches students out is actually just getting polar form. For me, we've already done the difficult bit, and the rest of it is quite straightforward. I want to get z to the power of 4. Okay, so z is equal to that, but I want to get that to the power of 4. So I want to get all of this to the power of 4. And on the next line now, I'm going to apply my Demoys theorem. So what I do with the modulus, I don't do anything fancy with my modulus. It's just 2 to the power of 4. So it just becomes 2 to the power of 4. But when I start dealing with my angles here, things change a little bit. Instead of multiplying cos 150 plus I sine 150 by itself 4 times, I just need to multiply the angle by the power. So it just, instead of cos 150, it's just 150 multiplied by 4 is 600. So it's just cos 600 plus I times the sine of 600. And that line alone, that's my Demoys theorem. So going from here to here, that's all we have to do with our Demoys theorem. And now obviously it's very straightforward. 2 to the power of 4 is 16. The cos of 600 is minus a half. And the sine of 600 is minus root 3 over 2. And there's an I in there as well. So to simplify this down fully, I just need to multiply out my bracket. 16 by minus a half is minus 8. 16 by minus root 3 over 2 is minus 8 root 3 times I. So my final answer there is that z to the power of 4 is equal to minus 8 root 3 times I. All I want to stress in this question is that don't be afraid of Demoys theorem. And actually Demoys theorem is very straightforward. For these complex numbers questions, make sure you're very comfortable with working out your modulus and working out your argument. It needs to be like clockwork, converting rectangular form into polar form. For me, that is the key to a lot of these complex numbers questions. So I hope this video made sense. If there's anything you're unsure of, then just let me know in class or send me an email and I'll try and clarify it.